number sequences. Now number sequences are just a set of numbers that follow a pattern, and each number sequence is called a term. So what we have here is this number sequence, and each one of these individual numbers separated by the comma is called a term. Two major ones we're going to be working with are arithmetic sequences, and they add a fixed number to the previous term called the common difference. So over here the common difference is going to be 5, because each time it goes up by 5. Here the common difference is going to be negative 1.5, because each time it goes down by negative 1.5. So the geometric sequences, same sort of idea, except for here it's multiplication. And you multiply the previous term by a set number called the common ratio. So here, for this one right here, it's going to be multiplied by 1/3. Now this one here, it's a little bit trickier because it goes up and down, negative and positive. So it's going to be multiplied by negative 2. And if you ever see a thing like that, then you know it's probably a geometric sequence with a negative number involved in it. Some sequences are neither type, and we'll cover a couple of those, but they still form a clear pattern. For example, up here, this here would be a geometric sequence, and you can figure that out. Well, we got 1/2, 1/4, 1/8, 1/16, 1/32, 1/64. So right there, that piece is going to be, well, if you're looking at the whole thing, it's going to be 1/28 of the whole thing. And that's just the way to think of it. Now, if you look here on the homework that you guys are going to have, you're going to have some examples of things here to do. So if you have to write a rule for the sequence and then find the next 3 terms, the first thing you need to do is you need to figure out, well, what is the rule? And I always like to start off with addition and subtraction to see what happens, and then go from there. So, because remember, subtraction is just adding a negative number, so it's the same thing as addition, just with a negative number. So here, how do I change this to this? Well, I subtract 9. And so now I look at the next one, and I say, okay, well, here, does that work? If I subtract 9 from this one, does that work? Yes, it does, so I subtract 9. And I subtract 9 here. And so the way I write this down is I say starts with with 63 and minus 9 each time. That's a pretty simple, easy to understand pattern. This one here, what I look is, again, is see if it's adding or subtracting. So here, how do I change this to this? Well, I've got to add negative 3. And then I go to the next 2, and I say, well, from negative 2 to negative 4. If I were to add negative 3 to negative 2, that would give me negative 5. That's not it. So then I go underneath, and I say, well, what would be multiplication? 1 times negative 2 would change that to that. So times negative 2. So I see, does that work? Does this times negative 2 work? Yes, it does. I see, does this times negative 2 work? Yes. So again, it starts with and you just, with the first number in the thing, start with 1 and times negative 2 each time. That's the end of our sequence. So, or that's the rule of our sequence each time. And so we could do this forever, and we would have keep on going and going and going, and we'd know what the next term would be. So if another part of your homework is going to be identifying these based on arithmetic, geometric, both or neither. So this one here, kind of odd, but it's just negative 1, negative 1, negative 1, negative 1. So what's going to be the next one? Well, it's going to be negative 1, and so on. But is this an arithmetic sequence? Well, yeah, it's plus 0. Is this a geometric sequence? Yeah, it's actually times 1. So in this case here, this one here is going to be both. Most of the time you will not get these because they're more complex. Now over here, we say for this one here, well, what's happening each time? Here, from here to here, it's plus 7. From here to, well, it's not plus 7, so it can't be arithmetic. And here to here is not plus 7 because the rule amount added each time changes. So here, now let's try geometric. From here to here, times 2. From here to here, times 2. From here to here, times 2. So it's going to be, this one here is going to be geometric. And so I'm going to write that over here. Let's see here if this part of my board is working here. So geometric. And what's the next one going to be? Next one on my board is going to be, well, 128 and then 256 and so on. Now this one here is a little bit tougher. I'll give you a hint right now. It's neither, because if we look here from here to here, plus 3 doesn't work. From 1 to 4 is plus 3. From here to here, it's going to be multiplied by 4. Multiplied by 4 doesn't work. I should have 16 there. And from here to here is not multiplied by 4. So it's neither, but it is something that we can actually figure out, because look, this is 3. This one, from here to here is 3. From here to here is 5. From here to here is 7. From here to here is going to be 9. So the next one's probably going to be 11. So the way we describe this is neither. And if we wanted to describe this, the way we'd say it would be that we start with 1 and we add the next positive odd number. So start with 1, add 3, and then the next time we add 5, and so on. So that's pretty clear, I think, how it works. This one here is my very favorite sequence, and it's called the Fibonacci sequence. And it's one of those things that actually occurred in a book called, a book that was a famous book called the Da Vinci Code. And all it is, it doesn't really work, because, well, 1 plus 1, well, that would be adding 0. And so it's clearly not an arithmetic sequence. So it's not adding the same thing as multiplying by the same thing. Well, this time this is going to be multiplied by 1. So it's clearly not, it's changing. So it's clearly not that. But the way this works is you add this to this, you get the next number. So this to this equals 2. This to this equals 3. This to this equals 5. This to this equals 8. This to this equals 13. This to this equals 21. This to this is going to be, well, what's the next one going to be, you think? Next one's going to be a grand total of, well, what's 13 plus 21? It's going to be 34. So this is called the Fibonacci sequence. I'll write that down for you because it's important for you to know for tomorrow. And if you look here, this is, it actually occurs in nature quite a bit. Like with sunflowers, the amount of seeds are governed by this, or the actual curvature pattern of a nautilus seashell. They're actually governed by that. So it's kind of cool. So that would be the Fibonacci sequence. And that would be important for you to know for tomorrow.